Hey everybody, this is Mr. Munson. We're in transformations. This is concept number 2, part 4, dilations. And so let's take a look at taking an object and making it smaller or bigger, and how to do that in the coordinate plane. Let's go ahead and get started. Now let's first start with a concept of just how I want to move points around. Right now I have a point sitting here at 3, 2. And suppose I wanted to make it, this is a certain distance away from 0, 0, the origin. But suppose I wanted to make it twice that distance, right? Far from there. Well, I could send it out here and measure and pull out a ruler and figure all those things out. But what I find is that if I go up 2 and over 3, like slope, then if I do that, it creates a right triangle, of course, and this hypotenuse represents the distance it is from the origin. Now, if I repeat that process by going up here and going up 2 and over 3, I can move my point, and now it's twice the distance away from the origin. Okay, so whatever that distance is. Now just take a look at these points and see if you can figure what happened. Here's my original point, and here's my new point that's twice the distance out, 6, 4. Now just look at that. It went from 3, 2 to 6, 4. It's twice as far out. Hopefully you can see that I just took the coordinates and multiplied them by 2. Now suppose I wanted to take the point and make it so that it's half the distance out. Come in right about there. And as you can see, that point would be 1/2, 1/2, 1. And once again, all I had to do is take my point and take half of it. So to move it up and down, say the rail that is represented by this point going up and down and moving twice as far out or coming in closer, and kind of coast along here. And if I want to make it half the distance, it's going to fall on that line. Here's the original distance, twice as far out. And of course, I could even go up 2 over 3, and it would fall out someplace over here. Now keep that idea in mind as we move to this next drawing. All right, suppose we have a triangle like this, and we want to make this triangle twice the size. So if you think about it, each one of those points represents, a point that's going to be sent out on its rail, if you will. Now it's really easy to do this in the coordinate plane because all I have to do is find the coordinates, multiply it times whatever, however size I want to make it, create the new points, and then plot them. Let's see what that means. All right, suppose I'm going to want to take and dilate this shape by half. Okay, that tells me I'm going to make it smaller, right? So go ahead and multiply each component by a half, create the new points, then plot it, and sure enough, we'll have a triangle that is half the size. Go ahead and put me on pause and do this work on your own. Okay, and there you have it. Now, if you take a look, sure enough that these points did stay along the rails and just move closer into the origin. Let's look at another one. All right, some shape like this is not going to, in the previous problem, all the points went out on their rails in that direction. That was because the entire picture was in quadrant 1. But if you take a look at this, we'll find that each one of these points are going to kind of shoot off in their own direction to expand the shape, right? So that's conceptually what's going to happen. All we have to do to dilate this thing by 2 is to simply come up with each one of the points and then plot them. Just understanding that you're going to take each point and multiply it times 2. Go ahead and put me on pause. Find out what the new points are and then plot them. Okay, so there's a shape that's twice as big. All right, and you can check your points over there on the right-hand side. All right, that's all I have for you at this moment. Let's go ahead and go practice.